Alright, welcome guys. So I have this question here. Prove that if the sum of the squares of the roots of the quadratic equation ax squared plus bx plus c equal to 0 is 1, then b squared is equal to 2ac plus a squared there. So now here, our focus here is going to be on these words here, the sum and then squares of the roots there. So now, if the roots of a quadratic equation here are alpha and beta like this here, then the squares of this here just simply going to be equal to s alpha squared and beta squared like this here. Now, the sum of these two roots here is equal to 1. So meaning that when we sum these squares of the roots that we have, they should be equal to 1 like this. Okay, so that's the first information that we have there. Then what else do we know? We know that the sum of the roots that we have, alpha plus beta, is equals to negative b over a, and then the product of the roots alpha beta here is equal to c over a like this here. So now here we have alpha squared plus beta squared equal to 1 here. Now we need to find the identity of alpha squared and beta squared here. So how do we get the identity here? We know that if you square alpha plus beta squared, if we expand this here, we're going to have alpha plus beta and also alpha plus beta like this here. Then alpha times alpha, we get alpha squared. Alpha times beta, we get alpha beta. Beta times alpha, we get alpha beta here. Then beta times beta there, we get beta squared. So then we're going to have that alpha plus beta squared here is equal to alpha squared plus beta squared. Then these two here, I like them, so I can just simply add them and then they'll give us 2 alpha beta like this here. Then what we do here, we know that in this expression that we have here, we have alpha squared beta squared here. So I mean that this side we make alpha squared plus beta squared the subject. So how do we do that? We push this, the other side of the equal sign, we're going to have alpha plus beta squared minus 2 alpha beta is equal to alpha squared plus beta squared like this here. So therefore now we get this expression that we have, we sub it into what we have there. So meaning that where there's alpha plus beta here, we're going to put this whole expression that we have here. So meaning that here we're going to have alpha plus beta squared minus 2 alpha beta is equal to 1 like this here. Then we know what the value of alpha plus beta is here, which is given by this, and we also know what alpha beta there, it's given by that there. So meaning that here we're going to have negative b over a squared minus here 2 open brackets c over a like this here equal to 1 like that. Then when we expand, when we get rid of the brackets here, we're simply going to have b squared over 2a, or over a squared, sorry, not 2a. So b squared over a squared minus 2c over a like this here. So this here is equal to 1 like that. Then we make this a single fraction here. When we make this a single fraction, we're simply just going to have b squared, or the common denominator is going to be a squared here. A squared into a squared 1 by b squared, we have our b squared there, minus a into a squared, we get a times that, we get 2 ac there, like this here. So this is equal to 1 there. Now this is the same as over 1. We do cross multiplication here, we're going to have b squared minus 2ac is equal to a squared like this here. To make b squared the subject, we shift this to the other side, then we're going to have b squared is equal to 2ac plus a squared like this here, as required in the question.